Hi, this is the answer key for the word problems worksheet. So we're going to go through how we would answer word problems either on a test or in lab or whatever. So when we look at word problems, we always want to have a system in place to actually answer these questions. And so what we should always do is look at the word problem, figure out what the goal is, right? So that's what you want. So it may say, find the mass in grams. Well, that's what we better get as our final answer. You take out all the information that's given to you. Some of this may be needed, some of it may be extra. This includes things like elements or compounds if we're talking about a chemistry problem. A lot of times it helps to diagram what happened, especially if it's something pertaining to stuff you do in lab. Then you triage. By triage, we mean figure out what type of problem it is, what equations I might use, etc., are based on that. For instance, if it's a molar mass problem, you'll have different sets of equations than, let's say, if it were a density problem. And then you solve, and then finally check. And one of the things you can check is, did you answer that question, that goal we talked about at the very beginning? All right, so the first part of the worksheet were problems that have no chemistry. So this one says John got 130 questions correct, and that this is 65% of the total number of test questions. What is the total number of questions on the chemistry test? All right, so this, let's see what we are given, right? We're given 130 questions. Oops, questions. And we want to know how many total questions there were. And I should say that this is how many he got that were correct. Okay, so what else are we given? We're also given that he got 65% of those test questions correct. All right, so there's not really a diagram, but this kind of says, okay, we're starting here. We want to get to the total questions. There's no other pertinent information in here. So now I can kind of forget about the word problem. Now I just have to use this data. All right, so triage, well, this is a percentage problem, right? We have percents here. And so let's remember what percent means. 65% means that it's 65 per 100. So 65 over 100. All right, so that's how we deal with percents. So let's think about this. Well, he got 130 correct out of sum total. We're going to call that X here. And that's equal to 65 over 100. So now we have our equation. Now we can solve for it. Now this is something we'll probably do again in the future, looking at how to solve these types of problems, solve for X. But the first thing you should usually do is cross multiply. So I'll take 130 times 100 equals 65 times X. Now I can get rid of this 65 by dividing by 65. So that means that X is equal to 130 times 100 over 65. Doing the math, this puts out, let me get out my calculator. So 130 times 100 divided by 65, that gets me 200 and questions. So did we answer the problem? Well, it asks how much did we, total number of questions, we got 200 questions. And another thing you can check is just, does this make sense? There were 200 total questions. He got 130 correct. Okay, that makes sense, right? 130 out of 200. That makes sense. What if I had gotten, instead of 200 questions, 20 questions? Well, if there are only 20 questions on the test, you can't get 130 right. So that answer we got makes sense. All right, so our next one, Beth and Sam are 500 miles apart. So here's Beth, here's Sam. The distance between them is 500 miles. Okay. We usually don't use miles in science. We use kilometers if we're talking about a long distance, but this is in 500 miles. She starts traveling at 1 p.m. and she's going 60 miles per hour. What time will she arrive at Sam's house? All right, so this is all the pertinent information we have. We have 500 miles, 60 miles per hour, and leaves at 1 p.m. So we want to know at what time X she arrives here. All right, so this, if we triage what type of problem it is, this is a speed problem, right? Where speed equals a distance over amount of time, right? Miles per hour, kilometers per second. Those are different speeds. All right, so if we go ahead and we say, all right, so the speed we have, that's 60. We also call this a velocity in science, but in everyday life we call it speed. Here is our distance, and our t, that's how long it's going to take. All right, so I can take speed times t equals distance, and then I can say that time equals distance over speed. I can now plug in those things, 500 miles, 60 miles per hour. Notice the miles will cancel out, and I'll be left with hours. So 500 divided by 60, that gets me 8.3. These all have 1 sig figs, but we'll just, 8.3 hours. Okay. This one's actually a little bit tough because we have to realize, okay, it's 1 o'clock. If she leaves at 1 p.m. and it takes her 8.3 3 hours, well, that would be 9.33 p.m. So let's convert this 0.33 into minutes. So this is another thing when we were talking about triage and figuring out which calculations. This is another thing we'd have to think about. Okay, what is a conversion we know between hours and minutes? So 0.333 times 60, well, that's 20 minutes. So it's going to take 8 hours and 20 minutes. And so 8 hours and 20 minutes after 1 p.m. is 9:20 p.m. All right, let's do another one that doesn't have chemistry. Okay, so a package of pens costs $3.45 p.m. All right, so here's our package. It's $3.45. We buy 2 of these packages. This one's also $3.45. Okay. And you take a $10 bill out. How much change will he get? All right, so this, obviously not a chemistry problem. This is just like an everyday shopping type of question. So, we know from shopping, okay, what kind of equations do we have? Well, whatever we have at the end, right? So that's going to be how much change we got. Well, the change is going to be how much we gave minus how much the cost is. So in this case, it would be $10, right? Paid with a $10 bill. And the cost, there are 2 times $3.45. And so that would be $10 minus $6.90, and that's going to leave us $3.10. That's the change he's going to get. Now let's go on to the chemistry problems. These are more like what you'd have on a test or in lab. All right, so a student obtained a clean, dry glass stoppered flask. The weight of the flask and stopper was 29.634 grams. I think this is from the lab experiment 1 if you've done that. So 29.634 grams. Then the student filled it with water, and now the mass of the water plus the flask was 62.479 grams. Okay. This is one where I really do think drawing stuff out actually helps, because sometimes it's like all this stuff, okay, you got the flask, then you filled it with water, and now you got a new flask. All right, so then we're given that the density equals 0.9973 grams per ml at 25 degrees C. And we want to figure out the volume in liters of the flask. So we know how all this water here, the water filled that up. So if we know the volume of the water, then we know the volume of the flask. All right, so this is, if we think about what type of problem this is, we have volumes, we have masses, and we have densities. So this is a density problem. And so let's go ahead and write down what we know about density. Density equals mass over volume. That's just one of those that we have to memorize. All right, so here we are given a density up here. We're given a density, and from these two, we can figure out a mass, and so we can find a volume. So we're going to rearrange this to get the volume by itself. So first thing I did was I didn't like this volume in the denominator, so I multiplied to get dV equals m. This v right here got canceled out. Then I divided by d to get volume equals mass over density. All right, it's kind of simple if I think of just the density, right? It's 0.9973 grams per ml. But what about the mass? Well, I have two masses. I have the flask and the water plus the flask. Well, notice that the density is for the water itself. So the mass I care about is the difference between these two things. And this is where a diagram can help, because the diagram you can see, okay, I only care about this blue stuff. All right, so if I do this math, 62.479 minus 29.634, I get 32.845. Divide by the density, and I'm going to get 32.93 grams. And that is how I did it, right? I started with the image or the diagram, and then I went ahead, did a triage, and then plugged everything in. All right, how many atoms of oxygen are in 52 grams of H2O? So this is a problem dealing specifically with H2O. So we're told 52.0 grams H2O. And we want to know the number of atoms of oxygen. All right, so this is a problem. We don't really have a diagram for this one. We don't have a diagram because, yeah, we're talking about minuscule parts. We're talking about atoms. But I can go ahead and I can say, okay, this isn't density because I don't have volumes or whatever, but I have masses, a mass here, and I have atoms. So what do I know? Well, I know a few things. I know that whenever we're dealing with masses of elements, we can talk about molar masses, which are grams per mole. And atoms, well, I have Avogadro's number, which is the number of atoms in 1 mole. And that's equals 6.022 times 10 to the 23. And so now I can kind of think, well, I can't go directly from grams to atoms, but notice I have grams to moles, and then I have atoms to moles. So maybe I can do this. Now, there's one other issue here, and that is we're changing species. So I need to realize that, okay, when I have H2O, that means I have 2 hydrogens and 1 oxygen. So this would be just the molecular formula, what that tells me. All right, so now if I want to do this, I can start off with 52.0 grams H2O. And I need to piece together all this information. So I can look the periodic table, and I can see that H is 1.008 grams per mole. Oxygen is 15.999 grams per mole. So for H2O, it would be 18.015 grams per mole. This is for H2O. Next, I need to convert from H2O to oxygen. And then finally from oxygen moles to atoms. And that would be 1.74 times 10 to the 24 atoms. Let's make that look like a 4. So that is doing this type of problem, right? Notice how this step right here is all just throwing down ideas, throwing down different things I know that relates these 2 different things, grams and atoms. Okay, so now a problem. What is the molarity produced when 50 mLs of water is added to 25 mLs of 12 molar HCl solution? This may not be covered in lecture, all of it, depending on where you are. But let's see what we have. So we're saying, what is produced when 50 mLs of water is added to 25 mLs of 12.0 molar, and this is something covered in class. This would be moles per liter. So here's my HCl solution, and I go ahead and I add 50 mLs. So what happens? My volume increases. And I want to know what the molarity now is at the end. Now, this is one of those things where if you don't haven't covered it in lecture, it won't be obvious off the top of your head. But once you do this, you can notice, once you cover it, you'll notice you're adding water. Adding water is a clear sign that you have a dilution problem. So now we can go ahead and we can think of, okay, what kind of problems are associated with dilution problems? Or what kind of equations? Well, we have C1 V1 equals C2 V2, where the C and the V, those are the concentration and the volume of what I start with. That's what we call number 1. And what I end with, that's 2. And molarity 1, liters 1 equals molarity 2, liters 2. This is the same equation, but specifically for molarity in liters. But we're going to use this first one here. All right, so I can look at it and I can say, well, 25 milliliters, that's a unit of volume. So this must be a concentration. I want to figure out my concentration here at the end. So what's my V2? Well, I have 25, I add 50, and so I get 75 ml. So I have V1, C1, V2, and C2. So I want to rearrange this to get my C2 by itself. So I can go ahead and divide by V2. So I get C2 equals C1 V1 over V2. Plug in, so I have 12 moles per liter times 25 ml over 75 ml. And I get 4.00 moles per liter, or 4.00 molar. Now, the last thing we always do is we check. So what does it ask for? It asks for a molarity. We ended up with a molarity. So that's good. The other thing is try to think back about what do you know about dilution. Well, in dilution, what happens? Your concentration decreases. So if you went from 12 molar down to 4 molar, that makes sense.